Hi everyone! We will present our work, explain what a Treemap is, exploratory investigation of strategies for explaining unfamiliar chart to blind and low vision users. Beyond basic chart types such as bar chart and line chart, many complex charts have been designed and used in the wild. For example, violin plot, heat map, Marimekko chart, and bubble chart are commonly used online to communicate data. Can this be a challenging task for BLB users? The answer is yes. Many BLB users understand digital data visualizations using alternative text. Many guidelines prescribe that the alternative text should start by mentioning each chart type so that screen reader users can easily fill in the details. For example, the alt text for these visualizations starts with "This is a heat map." However, the problem is that many BLB users are only familiar with basic chart types, so the explanation will probably be unhelpful. In this work, we explore text explanation generation as a solution and try to answer these questions. How do we explain a chart type effectively when users are not familiar with the chart type? What will be the best strategies for formulating a good explanation? First, we review data visualization taxonomies and define a chart type as a unique combination of mark, channel, data type, and coordinate system. For example, a typical bar chart has bar as its mark. It has two channels, position and length, which respectively encode a nominal and a quantitative data. Lastly, a bar chart has a Cartesian coordinate system. To find out the most effective explanation strategy, we first reviewed seminal education theories and identified three dimensions of explanation strategies as presented. We inspired this dimension by Oswald's theory of comparative organizer and Piaget's theory of schema. The comparing with prior knowledge strategy explains a chart type by comparing it to another chart type that the user already knows. For example, we can explain what a Treemap is by comparing it to a bar chart. But then, how do we decide on which chart type to use for comparison? The answer is we use another chart type that is similar to the one being explained. But then again, how do we know which chart types are similar?
To answer this question, we developed the distance metric between different chart types. The distance is calculated by comparing the specifications of two different chart types. This figure shows how the distance between a table heat map and a multi-line chart is calculated. There are similarities. Both encode a quantitative variable through position, which does not add to the distance. However, there are also differences, which add to the distance, similar in fashion to a Hamming distance.
Using this distance metric, we can find a chart type that is similar to the one being explained. To list some examples, a color bubble chart is compared to a multi-line chart with distance 4, and a violin plot is compared to either an area chart or a line chart with distance 2 and 3 respectively.
The second explanation strategy dimension is declarative versus procedural. We inspired this dimension by active learning theory. Declarative explanation describes what the chart type looks like, while procedural explanation provides a step-by-step instruction on how to draw the chart type. The last strategy dimension is abstract versus concrete. We inspired this dimension by Oswald's theory of advanced organizer and Squire's theory of example-based learning. An abstract explanation describes what the chart type is, while a concrete explanation describes a specific instance of a chart type. For the experiment, we consistently used examples related to fruit so that users are familiar with the topic.
We also created a prototype system that can automatically generate a text explanation using templates. The system is given a chart type definition and generates an explanation according to selected strategies. This figure shows how an explanation for a nightingale chart is generated by the system. To test which strategy is effective, we conducted an experiment with 24 BLV participants. We asked them which chart types they are familiar with beforehand to leverage their prior knowledge. Participants read an explanation for a chart type that they did not know. They then drew the chart on a paper and answered questions that test their comprehension. Each participant was shown 4 explanations. We also conducted interviews afterwards to learn about their needs and preferences. Lastly, participants completed an individual trait survey. Following this rubric that we developed, we evaluated participants' drawings and their answers to the questions to see which explanation strategy was effective.
Here are the results. Within the first dimension, we found that no strategy was particularly more effective. We found that comparing with prior knowledge can cause a strong priming effect that gives misconceptions. These swarm charts drawn by participants sometimes had 2 axes when they were explained by comparing it to a scatter plot. Future systems must prevent and resolve such misconceptions. Furthermore, some participants possessed inaccurate prior knowledge which disrupted their understanding of the new chart type. Future systems must make sure that the user's prior knowledge is sufficient. If not, the system can curate a sequence of chart types that the user can learn. For example, to explain a violin plot, the system can explain a histogram first and then compare it to a violin plot afterwards. Nevertheless, some participants found comparisons to be helpful, often when the explained type chart was simple and when the 2 charts being compared were more similar. Declarative versus procedural explanation, many participants did not prefer one over the other. However, in terms of task performance, declarative explanation was significantly more effective than a procedural explanation. For abstract versus concrete explanations, majority of participants preferred concrete explanations, with a few preferring abstract explanations. However, there was no significant difference in task performance between the 2 strategies. Some participants wanted even more specific examples. This implies that there can be different degrees of concreteness, and future systems must support this spectrum to satisfy user needs. We found that participants with a more external locus of control and with a higher spatial ability performed better on the question answering task. This is consistent with prior findings with sighted users. However, the 2 traits did not reliably impact their performance on the drawing task.
Here are some other observations that can guide the design of future systems. Many participants were more comfortable with thinking color as texture. These drawings show that they use texture to indicate color. Here, participants had trouble understanding how a stacked bar chart looks like. We can see that they drew them wrong, but in a different way. Future system must address this difficulty.
User preference of explanation strategies varied. This hints to the need for a personalized approach on providing explanations. We also noticed that the effectiveness of strategies does not always reflect the participant's preference. So, recommending appropriate strategies according to the chart type could be a good design. Lastly, participants had trouble understanding some terminologies, especially around circular chart types. Which words to use to convey various visual concepts clearly must be investigated. Thank you for listening.